happens when you have something called nuclear decay, and I'm going to just, there's a few minutes that I have to talk about this because it does relate to energy, is because we know what a nuclear bomb does, right? It's like a massive, outrageous amount of energy. And so in nuclear decay, what happens is some particles, this is trying to show, this is a nucleus, where the yellow things are protons in the nucleus, and the orange things are neutrons in the nucleus. And in nuclear decay, some particles change. They fly off, or they stick on, or something. This one's showing alpha decay. So there's 3 types of nuclear decay. So first of all, we need to understand the nucleus, where we can have protons and neutrons. And basically, if you know anything about, like, let's pick something like carbon. And usually that's a 6 and a 12, and that is the number of protons. And this is the total protons plus neutrons. So that means this carbon has 6 neutrons and 6 protons. And sometimes you write the element symbol like X and put a Z like this and an A like this, or whatever. It's the same, like, that's just sort of the general thing. Now, if we have something called an isotope, then what happens is it's the same thing, carbon. So it has the same atomic number, 6, 6, so it's carbon, but it has a different number at the top. So this has 6 protons and 6 neutrons. This one has 6 protons, but 8 neutrons. So it has a different number of neutrons. An isotope is the exact same element, but with a different number of neutrons. So then the nucleus is held together by something called the nuclear force, and there's neutrinos and there's antineutrinos and so on. But really what we're caring about is, what is radioactivity? What happens when something is radioactive is the nucleus isn't very stable. And so what it does is it changes the number of protons and neutrons by flinging off a particle or actually changing something. So this guy named Becquerel discovered there's some radioactive elements, and there's 3 types of radioactivity: alpha, beta, and gamma. Alpha decay is where you take some particle and you get rid of, do I have anything? Okay, you peel off 2 protons and 2 neutrons. Now, you can write it like this: alpha, 2 protons, and there is 2 plus 2, right? There's my 2, gives me a total of 4. 2 protons, 2 neutrons. So if I had something like carbon 14 and 6, and I did alpha decay, I'm going to write it as, I can write it as alpha 4, 2, or I can write it as helium 4, 2. It's the same thing. All I do here is I keep, let me find my periodic table because I don't remember. I have to keep the top numbers the same and the bottom numbers the same. So on this side here, I have a total of 6. So on this side here, I have to have a total of 6. So what I have is element, there's a 4 here. And how do I know what 4 is? I go to my periodic table and I look up element number 4, and it's beryllium. So this 4 tells you what number it is. And then on the top, I just subtract, okay, 14, this has to be 10, and this is, the top number is not very relevant. So what happens in alpha decay is you always get an alpha particle, and the thing that you had changes into a new element. in beta decay, there are two kinds of beta decay. Something called beta negative and something called beta positive. And what happens in a beta positive and beta negative decay is, I put on the board, and I remember it, and you need to remember these. Negative starts with a neutron, negative neutron. Positive starts with a proton. So what happens, and I have to keep the charge consistent. So I have a negative, I have no charge here, so I have to end up with a total of 0 charge, so a positive and a negative. So a neutron actually turns into a proton and flings off a bit of a negative charge. Or in this one, I have a proton, and it actually gets rid of its positive charge, and it turns into a neutron. So my examples, if I have beta negative, I have carbon 14, let's say, and I'm undergoing beta negative decay. 14 stays on the top because I have 0. I have 6 on this side and I have -1 on this side, so -1 and 7 is 6. Element number 7 is nitrogen. So if carbon undergoes beta negative, it turns into a nitrogen. If carbon undergoes beta positive, then on this I need 5 plus 1 would give me 6, and so that is boron. And so I write like that. So alpha means I take away 2 protons, 2 neutrons. Beta negative means I have to turn a neutron into a proton. Beta positive, I turn a proton into a neutron. And gamma radiation means that it's just high energy. And you can have, there's no mass change whatsoever. So you might have something like this. Here's carbon 14 and 6. And I get something like this, carbon 14 and 6. And I want to know what the mystery particle is. There's no number change, so I have to say it's this one. Okay, so that's really all we are worrying about in that particular thing. Often things that are high numbers are the ones that are radioactive. We don't care about any of this right now. You don't have to worry about that. That one's kind of, we've just done that, so I don't think I'm worrying about that either. Okay, here's another example of alpha decay, which is this is the same thing as writing alpha 4,2. So this is in a nuclear reactor. Uranium turns into thorium, and a hydrogen or an alpha particle flies off. So that's part of what nuclear reactors are. That's big energy, which we're going to talk about. And Ernest Rutherford was the guy that figured it out. We can talk about his experiment pretty much in chemistry, so I wouldn't worry about